Hello everyone. Welcome to our last React lecture. This one is entitled Concluding React. But I prefer to think of it as really this is our beginning of the adventure of React. We've gone through the basics of React and covered a lot, but there's a lot more to learn. React is a big world and there is a lot more to learn. So let's just think of this as not the beginning of the end, but rather the end of the beginning. A famous quote from history. So we're going to cover a few React concepts, and then we'll get right into it. We're going to write ourselves an API app and a React app together. In other words, we're going to write ourselves a mini final project that contains both the back end and the front end app together. And then we'll go ahead and build that. We talked briefly about doing a React build, and now we'll do it all in a single step. And if we have time at the end, we're going to deploy this complete finished mini final project to a cloud server so it's available on the internet. So let's get started. So let's start with a few of the basic concepts of React. So let's say we've applied for a job and they called us in for our initial technical interview and they ask us some simple questions. When I give interviews, I like to ask very simple questions of candidates, but questions that they really should know the answer to if they're coding. I don't usually ask too many coding questions. I ask more questions that involve their day-to-day coding. So for instance, let's ask the question, what is a React component? Who can answer that? Yeah, that's right. It is a function that returns JSX. Of course, we're talking functional components, not class components. Okay, so a React component is a function that returns JSX. Okay, so knowing that, then what is a render? We hear this term, or a component. What is a component render? Yes, exactly. It is to run the function. And if you think about it, that's all it could be, because since a React component is a function, here is our React component, this is our app component, this is a function. There's really only one thing you can do with a function, and that's run it from top to bottom. So really there couldn't be any other answer than to run the function. Okay. So since a render is to run the component function, well, what causes a render to occur? Yeah, thank you. Exactly. It is a change or an update of state. Technically of props, if the props of a component change, that component also renders, but really props are just state that came from somebody else or state that came from the parent of that component. And if that parent state changed, it will render and cause its children to render. So technically, really, it is a change of state. And really, this is why it's called React, because it reacts to changes of state, right? And one very important concept is state, and we know that nothing happens unless state changes, which is really the same as this. But this is a really important point and one we tend to lose sight of. I'm going to put an asterisk. Remember this. Nothing happens unless state changes, or nothing happens on the browser unless state changes. And a lot of times this statement can solve a lot of bugs. If you notice something's not changing on your browser, it's probably because you didn't update some state. Right. So these are some very basic concepts, but it is easy to lose sight of the basics. So try to keep these in mind, these 4 things, when you're coding React. So let's jump in and we're going to start coding our little mini final project. We have here 2 directories, one for the client and one for the server. This is a server Node Express program, and this is a React program, and they are separate. They are 2 distinct programs. Oftentimes, you might have one different team working on the server, the API, and another team working on the React. Now, in this case, we'll be just one team working on both together, but it's good to keep in mind that these are 2 distinct programs that really are not related to each other at all, other than the client makes API calls to the API. So let's start with our API program. Now this is a really basic Express app there, Server.js, and it doesn't really do much of anything. Right now it just returns 404 for anything. So this is a server app with Express, and looks like I'm starting on port 8080. So what I do to this, I'd probably start by giving it some kind of route. So app.get, and I'm going to get some endpoint, usually /API. APIs, or endpoints that return JSON, always start with /API/something. In this case, I'm going to just get status. I'm going to ask my API, what's your status? It's a very common endpoint, usually a heartbeat or something. Is the API alive? Okay, and it'll be the usual suspects. I'll give it request and response. There. And I can return something. I'll go res.json. And return just a simple object. We're going to hard code it here because we're not going to do any database today. We're going to really be hard coding all of our responses right now. So I'm going to have it respond just with a version of the API, and I'll give it some random version, maybe 1.03, just to instill some confidence that it's not 1.00. And there. Now I have an endpoint stubbed into my API. So I can go ahead and start my server. So there I am. I go npm run local, and I've got NodeModel installed, and there is my Express app running. Go to my browser, and let's take a look and see if that endpoint works. This is localhost 8080 /API/status. And we do. We get our version. So it's working as expected. I'm going to use a different app because all this works well. It's kind of hard to see the answer, so I'm going to use an add-on or extension to my browser. It's called Rested. It's a really great, simple extension to your browser. There's a version for Chrome and one for Firefox. Super easy to use, much more so than Postman, because it's really just part of your browser. All right, so I'm going to go ahead and do the same thing. Take my API status here, do a get, click send, and I should get the same result, and I do. A nicely formatted JSON response. So now I know that my API is working. Now I know that my endpoint works. I'm going to use it in my React app. So I'll switch from my server code to my client code, and I'm going to make myself a custom hook to handle all of this data. And that's a fairly common practice. Make myself a directory called hooks, and inside that I'll make myself a file called use. I'm just going to call it use data for lack of any more imaginative name, and I'll call it .jsx because Vite does like everything to be called .jsx. And I'll make myself a custom hook, which of course is just a function use data. And in my use data hook, I'm going to have it load some data. Now we know that loading data, we have to use a use effect if we want our code to run when this function is run, which is what I want. So when this function runs, or when the component that contains this hook runs for the first time, I want it to fetch all the data. That means I need a use effect, which I have a snippet for here, use effect. And I want it to fetch the data from the endpoint. I'm going to use Axios, very popular library for doing data fetches. We use fetch as well. Fetch requires an extra dot then. So I'm going to use Axios today just to do something a bit different. Axios.get. And I'm going to go ahead and going to fetch from /API/status and returns a promise .then, and I get back a response in my callback. And for now, I'm just going to console log that response, or the res.data, because with Axios you get back a .data as the thing. All right. Now let's export our custom hook. So let's export use data, and we're going to make sure we import use effect because we didn't do that. Now sometimes Vite gets confused and it doesn't let you import. So I find what I do, if I add import React to my code, it seems to fix it, and now it'll find my imports. Not quite sure where it does that, but that does seem to happen occasionally. Not a big deal. So now we have a custom hook that we can use, and although it doesn't have any state of its own yet, we're going to add that later. What I should also do is I should import my Axios. So I believe that package is installed. Let's take a look at our package.json. It is installed, so I'll go ahead and import that into my custom hook. Import Axios from Axios. Now let's go ahead and use this custom hook in our app JSX. There it is. And we're going to call the custom hook just directly like this. Use data. And we're not going to do anything with the return value because right now it doesn't return anything. We just want to see if in fact this gets called. We'll make sure we import that. And there it is. So now we can open up our component inside our project. So we'll go cd to client, and I should have my front end code here, and there it is. So I'll go npm. Now it is Vite, so it's run dev. But what I have done is I have actually, because I'm so used to doing npm start, I went ahead and added a start command to my package.json. This is just personal choice. Vite does use npm run dev, but I'm so used to doing npm start that I added a start just for me. So I could go npm start. And there's my Vite running. I can press H and I get the options R to restart and O to open in browser. So I'll just press O and my app should show in the browser. Now I'm going to add some state to my use data, and I'm going to have a number of different things I'm going to be saving. So right now I'm going to add some state, and I'm going to save this status object that I got back. So I'm going to make some state. I'm going to call it status and set status, and I get back an object from my API. So I'm going to initialize my status to that initially. Okay, and now I can have my custom hook return that state. I'll return it in an object, and I'll just say status. And now my custom hook returns an object with the status state in it that was fetched from my use effect. I'll also make sure that I import use state just to make sure. There. Now you notice I haven't really saved anything yet, so what I'll need to do now, I'll need to make sure that instead of console log my data, I need to save that data in state. So set status, and I'll set that to my res.data. And I don't really need that console log anymore, so I'll comment that out for now. Now I can go ahead and use this in my app component. So now I have a return value from my use data, so I'll destructure that with status, and I have this, and I'm going to go ahead and console log the status here to see if it's now available inside my app component, and I'm no longer console logging it here, so I should see that, and I do. When my component renders, I get a status. Let's just do that again to be sure. And it does, and the console log did in fact come from app. We can ignore that fave icon error. There's a way around that, but we're not going to bother with that today. Now what I want to do now is to render the status in my browser. I'm going to make myself a component to do that. So I'm going to make myself a status component. So in my client code, I'm going to make myself a directory called components, which is the general convention for components, and I'll make a file inside that called status.jsx. Now this is one way to make simple components. Sometimes you will see in some organizations, instead of having just the file in components, you might see a directory called status. And inside that, you would see an index.jsx, and that would be the status component. The advantage of this is you can bundle everything together in one directory. So for the status component, you would have its JSX file, index is the default, and maybe it's CSS files, maybe some test files, everything to do with a status component. It lends itself very well to working in teams where maybe one person would be assigned to a component, so they can work on that component in isolation just in their status directory and put everything they need inside that, and then it can be merged back into the main project. We will be doing that here today, but it is something to keep in mind. It is something that is commonly done. But for now, we'll just make a simple status component. So make a component. Now I've got a snippet that creates a component for me, which is very useful. Snippets are really great. I use them all the time. You can declare your own or define your own snippets under preferences. Use your snippets. They're really handy. I've got this, and I made one for a React functional component. You can also import them as browser extensions if you type in React, you're going to get a lot of snippets, or React snippets, even more precisely. And there's a lot of them. React snippets, just lots of snippets for React. Just be careful when choosing them. Make sure they're relatively recent. Let's look at this one. This one was last updated last year. So this is probably a good candidate. It will have all the newer hooks in it. Some, if they predate 2019, they will not. So if you want to use some pre-programmed snippets, just pick one of the ones that are slightly newer. In my case, I just built my own, and I found it was pretty easy. All right. So for my status component, I'm going to make this a section just for fun, and I'm going to have it render its props, and it's going to get the status object that we have in our main. So that's going to be props.status. So I want to render my props.status, and I know inside that I got a string version. So let's render that string version right here, and we'll leave it at that for now. Let's go and use this inside our app component, and let's just put a status right here. Status component, which it found, it auto imported it, and it got a props.status prop, so it needs a status equals status. Okay, let's take a look, and in fact it renders, and there is our status. Let's add some really simple styling to this. I kind of like having some code, make it look nicer. I think I've added some styling for a code. I use the code tag to show things like raw data, in this case the status, coming back from the server. How's that look? It just shows it in red and Courier. It's kind of silly, but just some fun. I'll also add to this maybe just a title or some other text. I'm going to put just a fragment in here for now. And I'm going to say the API version. There. How does that look? Okay, maybe add a space in there. I think it'll accept one space. There. That's not too bad. So now when my app starts, it shows the version of the API. So when I run my app now, I know that the API is running. Now, what if something goes wrong? What if my API is not running, or I get back some error from my use data fetch? I probably should handle that. So I'm going to add a .catch to my API call. ERR is the common parameter that we use, and I want to save that error. I'm going to log it because it's always a good idea to log something. ERR.message, and I do log error messages to the console in the browser, so I know what's going on. But I also need to have my error available to be used by the consumers of this hook. So I'm going to make some more state just for that error. Error there. And it can be just undefined, because if there's no error, I want it to not exist at all. And I'm going to set error to ERR.message, so now it can be used by any component that calls this custom hook. So I also need to export that error so it's available. And now in my app, I can now also get back the error, structure that error, and I can pass that along, error equals error, to my status component. I'm going to modify my status component so if it gets an error, it's going to render something different. So what I will do is I'm going to wrap all this code in some curly braces, and I'm going to say if not props.error and. So I'm going to render this code if I don't get an error. Now you notice I've got a bit of an issue because I have two sibling elements side by side. Let's make that more obvious. There. So instead, these need to be wrapped again in a fragment. Although what I can do, I can simply take that end fragment and put it there. Because we do know that React has this single parent rule. Everything must have a single parent. So let's make it more obvious. This is what we really have. There. So now we have these two elements with a single parent. And that's a really hard rule with React. All children must have a single parent. And now if there's no error, which there wasn't, it does render. And I'll add a space in there. So now it ignores my space. So what I can do, this would have to be inside another element. I can make another fragment. It doesn't hurt. Fragments do not render. So there is absolutely no cost to having render. And now I can put a space in there and it notices that. It's also good practice to have elements as children if there are more than one children. It's not a really good practice to have children as content and an element, although it is allowed. It's not really a good practice in XML in general. If you have more than one child, those children should be elements themselves, and we've added a fragment to make that happen. So now our status component is looking good, but now if we do get an error, well, I want to render that error now. So if I get an error, I want to render that error. So I'm going to duplicate this, and now I'm going to say if I do get an error, well, I'm going to go if props.error and I'm going to say maybe API error. And I'm going to render props.error. Now you'll commonly see two exclamation marks or a not in front of something if it is not a Boolean. In this case, props.error can be undefined or some text, and text does render. So you'll commonly see this pattern, not in front of something that's not a Boolean, and it converts this to true if it has text or false if it's not. Very common pattern. And looks like it works. Let's go ahead now and test if our status component renders the error. So the best way to do that is to maybe just shut down our server. Let's see what happens with that. So we'll go to our API and we're going to shut it down and see what happens. We render our app. We do get the error, request failed, which really just means our server wasn't running at all. So it looks like we are able to render errors. And now we're going to start up our API and watch what happens. So start up again, API run local. Okay, and does work. We need to add one more feature because although it's not apparent here, what could happen is if we get an error, you notice it's persistent in our used data. That error never gets reset. So what we should do is probably before the Axios.get, we should set error to either null or undefined. I'll make it null. It really doesn't matter. This way, we won't get old errors bleeding into our code later on. And this is common. Okay, so now our app, refresh it again, and it's great. All right, so we pretty much got our status component working. So now we have a pretty good working React app. It really does everything a React app should do. It renders, it makes an API call, it conditionally renders that results of that API call to the browser, but it's a pretty simple app, and I feel like adding something a little more interesting to this app. So what I want to do is have my endpoint now return something else. I want it to return some actual data when someone does a GET. Now, normally we would have our API connected to a database, for instance, and have maybe a Postgres query to fetch our data, but we're not going to go there today. We're just going to stub out our data. We want to get our API working as fast as possible. What often happens in a project, you have different people working on different things. You have one person working on the database, or more than one people, and other people, or one person working on the middleware, and people working on the React. And we can't have them waiting for each other. The React people, they need a working API as soon as possible. So we're going to give them that really quickly. They need a GET that will return the data for this API. So I'm going to give it some fake data. It's going to make myself a variable. And now I have some data, some characters, some popular shows, and Tom Cruise, just for fun. And I want to create a GET endpoint that will return this data. So we'll take this GET. I'm a big fan of copy and paste, although it does get me into trouble quite often. And I'm going to say API/data there. And this endpoint should return, well, my data. I'm going to have it return an array. Now, before I test this, I'll take a look and see, and it looks like I do have an error. I have this unique ID function, and I am calling this here. Because I'm stubbing out data and not getting it from a database, I had to generate some IDs, and I used this unique ID package. So I should probably import that unique ID package into my code. I believe I've installed it in my package.json, and I have, so I'll just import that into my server.js, just like that. And now my app starts, and I can try and test this in my browser. Let's go to my rested, and we're going to go to API/data, and I should get back the data, and I do. So now my endpoint's working. So really, in just a few minutes, I was able to create a working endpoint that gets the React people working. We don't have to say, I'm sorry, we don't have a database up yet. I can't give you your endpoints. Well, they don't want to be waiting. So to get them going very quickly, we do this in projects. We make some stub or fixture data and have our endpoints send that out. Now that we have a working endpoint, we can go back to our client code and we can modify our use data to also fetch that. Now there's a couple of ways I can do this. I now have two fetches that I want to occur when my application starts. Now the easy way would be to simply have two use effects and have one of them just fetch API data. And that works. And I should save some state for my data. So I'll copy that and have data and set data. And I know that data comes back as an array. So always be sure to initialize your use state. And now we're going to set data to res.data. And we're going to also export that data from our custom hook. So now when my app starts up, it should fetch both these things. Let's go to our browser and watch what happened. So, well, nothing obvious seems to have happened here yet. Let's look at my logs. Oh, now it's making two API calls, so that's great. I'm going to look at my React Dev Tools to see, did this data now end up in my state. And this is really the most reliable way to find out if something worked. Go to my app component, and it has its state, and there it is. There's the first one, which is the status, and there is my data saved. So now I have two states in my app component that I can use. So this is one way I could have my custom hook load all my data. There's probably a better way, because as you see, I'm sharing this error state. So if this one had an error and this one did not, I really would be overwriting one error with no error the next time. So there's probably a better way to do that, and we'd normally use something like a promise.all to fetch all of our data all at once. So what I can do instead is make this into one use effect, and I'd have promise.all, and promise.all takes an array of promises. So I'll give it the first promise, which is this axios.get status, and the other one is the axios.get of the data. So now it's an array of promises. You also get back a dot then, but you don't get back a res. You get back an array of res. We commonly call that all. There. And now I can really do the same thing, but now I've got all 0 and all 1. So with my status, I'm going to set it to all 0.data, and my data, which I have here, to all 1.data. As you can see, it's actually a much more compact way to do it than having two use effects. So I can delete that, and I can delete all this as well. There. Great. But there is also a catch. No pun intended. I have to do a catch, and with a promise.all, you only get back one error message. You don't get back an array of errors. There's a different JavaScript function called allSettle that does that, but for our case, promise.all is great because we want it to fail. If any of these fail, we want the whole thing to fail. So now we're fetching everything, and if any of these two promises fails, or these two fetches fails, the whole thing errors out. Okay, well, it does appear to be working. Go to my app, and it works exactly the same. A little more compact, and now it's a little more robust, where I'm guaranteed that both of these will work or nothing will work. Now that I have my custom hook fetching the data list, I can have my app render that. And what I want to do, I want to create a list. I want to render a list of the items I got back. So I'm going to make myself a component. I'm going to call it data list.jsx. Not the best name because data is such a generic name. So I generally wouldn't use that, but this really is a generic example. So I'm going to go ahead and use that. So let's make myself a React functional component. I've got my little snippet here that I wrote there, and it's called data list, and I'm going to have it render in a UL. I'm going to have it render the items that I get back. I'm going to get essentially props.data is what I'm going to get. So I'm going to render that props.data. But what I want to do is I don't want to render them directly as LIs. What I really want is I want to have an item. This is a common pattern. You have a list and then you have list items. For example, I would have a data list item or an array of those, maybe inside some array. That's what we normally render. Now ours is very, very simple. It's just going to be an LI with the name inside it. But we're going to do that anyways. So what I need to do is first make myself a data list item component. So we call it data list item.jsx. It's a component. Okay. Now this doesn't have any state of its own, so I don't really need my state here, because all it's going to do is going to render the props that it got, and it's going to be an li. And I want to render my props dot, and I'm going to get the item, and inside my item I have name. Let's double check my data in my server.js, and yeah, every item has an ID and a name. So I'm going to render just the name. Really, I know it's very simple, but it's not a bad idea to make a list item because you might add more features to the list item later on. So I almost always make one every time I render a list in React. So now I can go back to my data list and I can build a list of data list items. So in my data list, I'm going to get props.data. So in order to convert my props.data to an array of data list items, I use map. Props.data.map. Map is your best friend as a React developer. We use it so much. Okay, and for every item, I'm going to render a data list item. I'll put some curly braces and a return just to make it more explicit. There. And I'm going to return a data list item. There. And make a variable, call it const. I'll just call it list because that's what it is. And I can now render that list right here. In fact, I can make it all one line. It's just one thing. Makes it look a little cleaner and doesn't take away from the readability. Okay. Of course, my data list item is missing stuff. It's missing the item that it expects. It expects to get item equals. So I'll say item equals. It'll be this item inside the map. Okay. Now I'm ready to use my data list in my app component. Go to my app component. We're going to add our data list right here. Just like that. And the data list expects a props.data. So data equals our data. Now I haven't destructured data yet, so I probably should grab that from my custom hook. And now it is data. Okay, and take a look. And sure enough, I am now rendering those 4 items when the component first renders. However, if I check my DevTools, I've got this warning from React saying that each child should have a unique key prop. This is not an error. It is only a warning. React will work, but it really is not that efficient. It can really slow things down. So we really should have every child in a list give it a key prop. So where do we add this? Well, you might think you might add it in the li, but turns out that won't work. If I give it a key equals props.item.id here, what happens? Let's take a look. Let's refresh our app, and we still have that error from React. So what's going on? Well, that is because li, this is not a React component. So this is a HTML browser DOM element. So it doesn't know what to do with key at all. So that can't exist there. Instead, we have to put it in our data list item. So we're going to make this multi-line now. Item equals item, and we're going to give it a key as well. So it'll be key equals item.id, because only a React component can do something with a key prop. And let's take a look at our browser now, refresh our page, and the warning has gone away. What I want to do now is add some features to my list. For example, when I click on an item in that list, I wanted to delete that item. So what I need to start with is go to my API and make sure I have some way to delete the item. Let's go and start right at the back end. What we need is a route that will allow us to remove or delete an item from our list. So let's go ahead and make ourselves another endpoint. We'll have that. It'll be app API/data, but it's going to be, instead of a get, it's going to be a delete. And this is the common pattern we use. We've talked about CRUD, create, replace. We've heard this term CRUD, which is kind of a silly acronym, CRUD, which means for create, read, update, and delete. Well, this will be a delete operation. Now we're going to have it delete the record that we're interested in. So we're going to give it a param. We're going to give it :id as our param. And what we want to do is remove from our database, our in-memory database, the item that matches that ID. Okay, so let's go ahead and first off, let's get the ID. Make ourselves a variable, const ID equals req.params now .id. And there are a few ways we can remove things from an array. We can pop, but that's not really appropriate here because that would only remove the last item. We want to remove some arbitrary item from an array. And one of the easiest ways is using the dot filter function and simply replace data with the new array. So go data equals data dot filter. And for every item, we're going to only add every item where the item.id is not equal to this ID. So the filter callback returns true or false. If you return true, it adds that to data. If you return false, it is not included. There. So now we have removed the item, and we should probably notify the caller of this API that this worked. So I'm going to give a res.status, and since it's a delete, there's not really any need to return anything. So I'm going to say a status 204, which means a no content response. Let's go send no content. This lets the client know that not to expect anything in its res when it calls this fetch. Now let's test to see if this endpoint is working. We're going to go to our REST client, and here's our fetch. It still works. And we have these items. So we're going to remove one. Let's remove Tom. Let's grab that ID, copy that one right there. And the endpoint is API/data/ the ID. So let's put the ID at the end of that. I'm going to change this to a delete operation. And let's find out. Let's give that. Well, we got a 204 and no content. So it did succeed. So let's go back and do our get command, or a get request again, to see did it in fact remove the one we wanted. And now we should only have 4, and yes, the last one is indeed gone. So our endpoint is working. Now, if you want, we could have returned something else, maybe the length of the remaining items. But that wouldn't really lend itself well to a database. So I think returning a 204 new content is perfectly fine in a delete operation. So now we can use this in our React app. So we'll go to our custom hook, because the custom hook is the file that deals with all things to do with this data. Every operation on data should be done inside this custom hook. So what I need to add a function to delete data. So I'll call it delete item, and it will take an ID as a parameter. And what I'll have my delete item function do is it's going to do an axios.delete to that endpoint. We're going to use a string literal and go /API /data / and the ID. So there is our call, and we're going to do a dot then. Now, we don't really care about the res. We'll include it here, but we know we're not getting any content. But if we do get a then at all, it means it was successful. So if the then fired, it did work. So we're going to then simply change our data to the new data. So we got a then from our delete, but all that means is the back end data was changed. Our data hasn't changed at all. We also need to update our copy of this state. So this will be set data, and this is going to be also data.filter. We know it was done on the back end. We need to make sure ours matches that as well. So filter for every item where item.id is not equal to ID. There. Now, you may ask yourself, well, that's kind of odd. We're doing it here, and we're also doing it on the server. What's with that? Well, you got to remember, this is simply fake data we're using right now. We'd normally have a database call. This would probably be a PG query to delete from a table. So this is really just using an in-memory database. But this is running on our server. Our client, when we make a database call, we need to make sure that we remove that ID from the data if this API call was successful. If it was successful, we know it was removed from the server, so we need to reflect that in ours as well. And we're going to add a catch here to the end. Since we have a catch on everything, we'll simply add the same catch there. And we're going to export our delete item function. Now, a quick word about interface functions. What we have here is an interface function. In other words, it is a function that is exposed to the outside world that takes care of the implementation details of how to delete an item. Because you might say, well, why don't I just export my setData function from my custom hook? That's much easier than having one or two other functions that do all this. I just have to export one function and it can take care of everything. Well, this is really a bad pattern to follow. We should never expose implementations of state outside of this particular module. because this is an implementation detail. We do an Axios call and we do a set state. Well, now if I expose set state outside, now a component needs to know that it must make an Axios delete and update the state. So really not a good pattern. Instead, we have a function called delete item that takes care of all the details of what happens when an item gets deleted. And that's how we use what are called interface functions. Very important concept in software development. Now I have a delete item function that I've exported from my custom hook. I can now use that in my app component and pass that along to my data list. And now the data list has delete item. There's my data list, and now it has a props.delete item. Now I have a couple of choices. What I could do is I can just pass delete item down to my data list item. Let's try that. We'll go delete item equals props.delete item. There. And inside my data list item, I would then have perhaps some kind of on click. On click equals and call my props.delete item with the props dot item dot ID. Okay, and let's see if that works. And there's our list, and let's click on one item. We'll click on Roy, and yes, that does in fact work. I'm able to delete items when I click on the item. But let's take a look at this. Although this does work, this is actually a very bad pattern. And the reason I can tell, if I see props.delete item calling as a parameter props.item ID, this tells me right away this does not belong here. Whenever you see props.something with parameters props.something, you know this belongs in the parent, because we provided too much information to this component. It doesn't need to know that its on-click triggers a delete. It just needs to know do something when it's clicked. It doesn't care that it's a delete operation. It just needs to know it's been clicked. So generally, instead of this, we would simply say on-click equals props.onClick. There. And now this component doesn't know why it was clicked. It just calls whatever function it was given. And it is in the data list that has the knowledge, or that knows why it was clicked. So instead of this, I would go my delete item equals that, but I'm going to call it now on click. There. And call it here instead props.delete item with the item.id. There. And this is where it belongs. Now we have props.function calling something that is not another prop. And this is a sure sign of something being in the wrong place. If you see a function, props.function, calling parameters with props.something, you know it's in the wrong place. So let's try and see if this still works. Go to our code, and there's our app, and it still works. So now I have them all deleted. If I refresh, well, they're still all gone because my app only allows for deleting, and this is now persistent. What I'll need to do is actually stop and start my server to get my data back, and run it again, and I have them back. I want to add another feature to my application. We know that I can delete all these items, but once they're all deleted, we really can't use the app anymore. So I want the ability to be able to add items to my list. I'm going to have a little input field and maybe a button, so I can type and click the button, and it will add things to my list. So I'm going to start right at the back end and create myself an endpoint. And you probably guess it's going to be an API/data and a post. And that's exactly what we'll do. We're going to make a app.post. Still to API/data, and a post usually means create. Now there is a post and a put, and sometimes people use posts for both update and create, and that's perfectly fine. It really doesn't matter. I haven't found any real problem with doing it either way. Technically, we use the put to update, but honestly, it really doesn't matter. But in our case, we're going to do a create. So a post is generally meant to mean a create. And we're going to be getting some JSON. Now we expect to get back really an object that looks just like this, but it'll be missing the ID because our app is not going to know what ID we want. So we're going to get back really just an object with a name in it. Okay, so that's what we're going to look at. So we'll be getting back as our body a name. So let's grab that name. Name equals our request.body.name. And we're going to create ourselves a new item, const item equals, and we'll really make it look exactly like this. In fact, we can even copy that like that, and then make an object with unique ID, but it'll just be name. We can use the shortcut and just make our name like this. Now we need to add this new item to our data array. That's easy, it's just a push. We don't care if it adds to the end, and we don't have any issues with immutable updates in Express, certainly, so we really don't care. A push is perfectly fine here. There. And what to return? I'm going to return the item. So it'll be the object that was created with the new ID. So let's go to our rested first, and we're going to test, does this endpoint work? Go to rested, and we're now going to go API data, but now we're going to send a post. Now, rested has a couple different ways you can do this. You can go, the type can be JSON, and we can give it the key or the name equals name, and the value, we can give it anything. We'll just say Freddie Mercury, great star from a cool rocker band. Okay, Freddie Mercury, and we'll send that, and let's watch what happens. Now, I'm going to go ahead quickly and do a console log of the request.body. I want to see what did I get when I sent my post to API data with this. What do I get? Okay, let's go to my terminal, and well, look, I got an empty body. Well, that's odd because I know I sent name Freddie Mercury. So why did I get an empty body? Well, this is just a quirk of when you're sending requests from the browser. We need to add a header here. Content type, and it's application slash JSON. This is only when you're testing, because we didn't specify what data type we're tending. We're just going to tell it now. It's content type application JSON. Click send again. And now we notice that our body contained information. And the response was the item. So it looks like our endpoint is working. We can do a post, we can send it a body, and we can also get our response. There's a second way to do this. Instead of type JSON, if you have a more complicated data, you can send custom and actually paste in your object as JSON right there. And this is normally what I do all the time. I don't normally use type JSON. I go type custom, make sure you have a content type, and send it the JSON. So let's go another one, and I can't think of any other names. Let's go Ryan Reynolds, aka Deadpool. Right. Click a send, and did that work? It worked exactly the same way, and we got back our body. So what I tend to do when I'm testing my endpoints using a tool such as Rested or Postman, I send custom and I give it the JSON myself, so I know exactly what I'm sending. Now we know that our endpoint is working, and you probably guessed what the next step is to now have our React app make API calls to make use of this new endpoint. Let's go to our use data. And now we're going to create another function, which is going to be add item. Just make a function here, add item. Okay, and it will take as a parameter name. And we're going to do an Axios.post. And the endpoint's going to be /API/data, and post takes a body parameter. In this case, we're going to give it an object with name inside it. So an object with name equals the name inside it. We'll do our dot then, get back the response. Okay. And so we get back the item with the new ID. So we want to use this. We want to now add this to our state. We want to update our copy, and we'll add it to our state set data. We have to use a mutable update, of course. So set data is going to be a new array, spread the old content, and comma res dot data. Now this adds it to the end of the array. I kind of want the one I just added to appear at the beginning of the list. So I'm going to change the order. I'm going to now do this instead. I'm going to add the one I added to the front of the array. Okay, I'll add my dot catch, which is pretty easy. I'll just take that and add my dot catch right in there. And now I have an add item function. I'll make sure I export that. There, and we talked earlier about interface functions that hide the implementation details of what they're doing. So all anyone ever sees outside of this file is simply those functions. So now I've exported add item, and now I can use it. I'm going to go to my app, and now I have another function available, add item. Now, what I could do is I could just make a component, but I don't really feel like doing that right now, and it's something pretty simple. I'm just going to add it right here, my input and my button. I'm going to add them both right here. So let's put it right after our status. I'll make an input. There we go. And let's take a look. Go to our app, and there's our app. And just for fun, let's just make sure everything's working. And it is. There's no errors. Okay. Now I have an input. I'm also going to add a button to the right of this. So I'll add a button here. And I'll call that button Add. There. And of course, it doesn't do anything because neither of these are connected to state at all. So I need to connect my input first to some state. So I'll add some state to my app, and I'll put it here. Make some state. I'll just call it text. And use state. I'll start with an empty string. Very important when doing state for inputs, always give it an empty string. And then I'll connect up my input by giving it a value and an on change. So I'm going to say value equals my text and my on change equals. Now I could make a named function, but for inputs, they're really so simple. You commonly almost always see them inline. E and then set text to e dot target dot value. This is what you'd normally see. Type equals text. That's the default. I'm not going to put it there. I don't really care about that because really text is the default type of input. So now I have an input, and when I type, I'm hoping that it is updating state. The fact that anything is showing at all does tell me that it's working. But let's go to our DevTools and just make sure. Let's look at our state for our input. It's inside app. Make it a little bigger. And my state is right there. So if I type stuff in, there it is right there. There's my local state as I type. And it does change. This is great. So now I need to make my button do something. If I add an item, I want to click that button and have it, well, add the item. So on my on-click, what should I do? Well, a couple of things. I can make myself a function here called add item, but that would conflict with this name. So I could pick a different name. I could say add input item and call it that, but that's a little clunky. So instead of that, I can just do it in line. It is only a one line. I just want to call add item with that text as a parameter. So I think just doing it in line is easier. On click equals, just put this in line like that. And I'm going to say add item with the text. There. Let's give that a try. So I'm going to add a random name. Well, I'll add an old actress from the Golden Age. Betty White. Wow, that seemed to work. Wow, let's take a look at my terminal. Did I get the post? I did. So let's make sure everything worked. I'm going to refresh my app, which should load all of my items again. There we go. There's Betty. Of course, she got added at the end because my API did a push into my array. So it makes sense that I see that item at the end, but it looks like everything's working. I've got that blank one from my earlier test. Remove that one. Looks like my delete works as well. So now I have really a complete working app where I can add and remove items. Now let's talk about what we do once we have our application complete. We have it all complete and we are running it in a development environment. Right now we have our Express server running here under NodeMon, and we have our React app running under Vite, which is acting as our server. Okay, but we would not normally do this in production. In production, we would have a different environment. We'd probably running this off of a web server, such as Apache or Nginx or something else. And we would not be having it compile our source code in real time in a production app. Instead, we would build the app. And I think we talked about build in one of our previous lectures. This is where we take all of our React code here and we convert it into HTML, CSS, and JavaScript, because those are the only things that a browser can understand. Browsers can't read JSX, so we do a build. And in our package.json, we have a build endpoint. Let's go to our Vite. We're going to stop our Vite. We'll press Q. It does stop it gracefully. And we're going to do a build. So npm run build, and we'll see what we get from Vite. So it does a couple things. It was very fast. What did I end up with? Take a look. And I got a new directory called dist. Let's take a look in our VS Code. There it is. It's called dist, and well, it looks like it has HTML, CSS, and JavaScript. So Vite has converted our app into something we can deploy, something we can put into production. So how do we do that? Well, there's a couple of ways we can do that. We talked about that earlier. We can use a web server, such as Apache and Nginx, and put this code on it. But it turns out we already have a server in our project. We have our server here. It's Express. We can have our Express server serve out the static content now, because this is static content, which means it doesn't change. These three files don't change anymore. We can have our Express app serve out this static content. We can have Express serve out any static content we want. And to do that, we use the static middleware. We'd go app.use, and there is express.static. And it takes a path, a file path, where it should look for files to serve this route. Now, by default, it serves the slash, but we'll omit that because we're just going to serve slash. So if I say express static, and I have to give it some kind of location, in other words, a public directory. And what I want to do is I want to have my files served in public right here. So I'm going to have a public directory right at the root of my main project right here. So I want Express to serve files in public, but as you can see, public is one level higher than the server itself. So I have to use a bit of a trick to have Express find that. So what I'm going to do is I'm going to grab the current working directory. This is the directory that Express is running in, which is most likely server. And I'm going to, that is process.cwd, just a standard node function that gives you the current working directory that this process is running in. Then I'm going to make a directory or make a variable to hold the directory. I'll call it public equals, and we can use the path module as path.join. Don't worry too much about this, but it's pretty straightforward. Okay, and we're going to take the current working directory we just got, and we're going to add dot to it. That means the directory of the server, and dot means one level up. and then public. What this really means is the server directory slash dot dot slash public. And of course server is here. We go up one and public, and this is what we're going to end up with, which is going to be our project directory slash public if everything is done correctly. Okay, so now my Express app should be serving out static content. Let's take a look. Looks pretty good. It's all running. Let's give it a try. Let's put a really simple file inside our public directory. We'll call it index.html. And we're going to say hello. There's really nothing exciting here. We just want to prove that we can serve out static files out of public, and that Express will do that for us. So let's open up our browser and see if in fact Express is serving out static files on slash to our or from our public directory, and we should get hello, and we do. So this proves that Express is in fact serving static content from slash. Of course, this means we can't use any slash root down here because that will override this one. And by the way, this is the same thing. Just saying slash, which is just the default. And it should give us the same result. Go 8080, and we get hello. So generally, I often use this to make it more explicit what I'm serving out, but you can just do this, and the slash is assumed. You'll see it both done both ways in code. I'll leave it like this to make it a little more clear. So now we know that our Express app can serve out static files. So we have to get a way or find a way for our React app, our built React app, to end up in public somehow. I'll remove that old index.html. And let's take a look. As you've noticed, I've got my project here contains client and server, and each one of those has their own package.json because they are separate apps. And server has package.json as well. And inside my server, I've got npm start, and inside my client, I've got npm build and npm start as well. But you may have noticed I also have a package.json on the outside that is on top of both of the client and the server. And that is what I'm going to use to build and run both of these as a unit. Let's open up that package.json and just take a look inside that. Now this looks a bit overwhelming, but let's take a look what it does. So I've got a bunch of scripts here. I've got install server. Well, all that does is cd server and run npm install for the server. Easy enough. I have install client. That does a cd to client in there, and npm installs the client. Fair enough. I've got a build client. That goes cd client and runs npm build for the client. And you can see the pattern here. And I have another one called deploy client. What that does, it creates a public directory and then moves the dist files, which is what Vite creates for us, into that public directory. Okay. And then I've got a install, and what this does, it kind of combines. It runs npm run install the server and npm run install the client. So it combines both those installs. So this is kind of building on each other. And then I have the two main ones. I have build. So npm run build and npm start. What build does, it really does all of these. It runs npm install, which in turn runs install server, install client. Then it runs npm run build, which runs the build for the client. And then it runs npm deploy, which copies the files. So I should be able to go npm run build, and it should do everything for me, and I should end up with a package or a program all ready to go. And then to start it, I just cd server and npm start the server. Let's give that a try and see if this actually works. Run build. There's the installs. They're pretty quick because everything's installed already. Now it's building the package, and that was pretty quick. I did have a lot of things built already, but it did say it moved everything into my public. Let's take a look. Oh, and there they are. So now, if I start my server, it should now serve out these static files for me. Let's give it a try. So stop this again, and let's go npm run local, just our server. Let's just start our server right now. Okay, let's take a look. Let's go to our browser, and what happens now if we go to localhost 8080? And I get my React app. This is great. All in one step. Let's do one more thing. Let's go back to our server. Instead of go cd dot dot, and now we're in the root of our project. We have an npm start. Now all it does is cd server npm start. So if we go npm start here, it should really just start our server all in one step. No surprise. Let's just make sure React app opens again. 8080. And there it is. There is our app running. And now it really is a one-step build and an npm start. What this allows us to do now is to deploy this to a cloud service. Now previously we used to use Heroku for deploying Node apps, but they started charging for pretty much everything, so we kind of stopped using that. Let's take a look at some alternatives to Heroku. Heroku alternatives. And there's a bunch of them. Best alternative, there's a few of them. Okay, we have Netlify. We've looked at that one before. This one is more for static web content. There's Fly.io. This one's pretty good. I've used it before. And there's Render. This is a very good one. I like this one. What else we got? 8 more. Oh, lots of different choices. So I haven't even heard of. I've used Fly.io and I've used Render. They're both very, very good. We're going to use Render today because I find this one is one of the easier ones to use. And they have a free tier which lets us deploy apps pretty easily. Let's go into Render. Okay, so render.com. Okay, let's go there. Now, I've already created an account last night, so I'm going to go to the dashboard. And I have an empty account here. So what I can do is I can start a static site or a web service. Now this is called web service. What they really mean is an application, like a Node app, which is what we're going to run here. So although it's called web service, it really means an application. And I'm going to do one of these. So new web service. And we have a choice. We can say build and deploy from a GitHub repository. Now we have this project saved in GitHub right now. Let's try to find it. I think I called it Final. Lighthouse React Final. All right. So I've already connected my GitHub to Render. What happens is if you go next, it will ask you to connect a repository. I've already done this. I've connected this and I've connected this repo to it. In order to change this, you need to go into GitHub and go into your settings here, and you go to applications, and you can specify render configure, and you can tell it what repos it can see. I've said you can only see that repo, and I could add more. I'll do this. This is great. A nice demo. There. Now I'm telling GitHub that render can see these two repositories. Let's save. There. Let's go back to render. We're going to make a new web service from GitHub. It should now see two, and it does. Now, of course, I want to pick this one. So I'm going to say connect this one. Now it's very easy. You simply give it a name. So I'll call this React-Final, for lack of a better name. You can pick where you want it to go. In this case, it's going to be Oregon. That's the closest to us right now. And I'm going to have it trigger off the master branch. I'm going to use the master branch as the build. We might make a different branch. In this case, I'll use master. And root directory, we'll just leave it the root for now. Runtime is node and the build command. Now it's not yarn, it was npm run build, wasn't it? So npm run build. And my start command was npm start. And that's pretty much all you have to do. Yes, I'm going to pick the free tier because I don't feel like paying any money for this. And that should be good. There's a bunch of advanced settings. We don't need to worry about those right now. So it's very, very easy. I'm going to click Create Web Service. And it should go out to my GitHub, grab the code, and start building it, and spin up a node for me. Let's give it a try. Oh, it's doing something. Let's watch it process this. So now it's cloning my project from GitHub and running the same commands as we saw on the command line. npm install. A little slower because it hasn't been done before, but they got a pretty beefy server. These run amazingly fast. That was pretty fast. Running vite build, and now it's building, and wow, it built already. There's the mkdir, and there's the copy of all the files. Uploading build is going pretty fast. This is great. Deploying, build succeeded. Now I should see my Node app start. I think it's looking for a place to now launch this Node app and picks an appropriate port, and it should just say my app is live. That takes another second or so, or a few seconds. So as you can see, it's pretty simple. One click and we're almost deployed. Let's let this thing finish. npm start, there we go. Server started on port, whatever. We don't care about that too much, but now it is live. And they give me a URL for my app. In this case, name.onrender.com. This is great. I'm going to run this. Let's see what happens if I go. This is now on the internet. And there's my app being served on the internet. And anyone can see it and make sure it runs. It does. There. Here we go. We'll add James back. So yes, our app is totally live. This is great. Now, one interesting thing, because I have this hooked up and I've told it that it's watching the master branch, what I can do is if I make a change to my code, let's say I don't really like that name, Hello React Final. I'm going to change that to say my anything list, because it really is a list of anything. Let's go into our React client here, go into our app.js. Let's just rename this. Let's call this my anything app. There. Okay. I'm going to go ahead and commit that change. I'll just say changed title. Commit my change, and I'll do a git push. I'll just do the push right from VS Code. I'll just click sync here, and this is going to push the master branch. There. And now I've pushed master branch. Let's go to my cloud service, and we'll see what it's doing. Let's go to my dashboard. It says I have, wow, this one's deploying again. What's going on? Let's click on this one. What's happening here? Events. Oh, it noticed a new commit at here, and it's running again. I changed the title and it's building another app for me with my changes. So anytime I make a change and push master branch, those changes are live almost immediately. This is what's called continuous integration, where the developer pushes something and then it ends up on a server live within minutes. Okay. Now, oftentimes there are checks in place like tests, jest tests, end-to-end tests, which of course we've totally bypassed all that. We're just simply going right to the web. Okay, and this is, let's take a look. Deploy started. Let's watch. There we go. It's almost ready. Looks like it takes about, I don't know, it was about a minute and a half to deploy a new build. Okay, and it should say live in just a second. It is live. So let's go to our app, and now my Anything app is live. So what I commonly do, although having master branch is fine, what I often do is make another branch. When I have web services like this or cloud services, instead of having them trigger off of master branch, what I do is I make another branch. Let's make another branch here. Create a new branch. I'll just call it, I can call it anything, but I'm going to call this deploy-render. There. Make a deploy-render branch, and let's push that branch. There. So now I can change my render so that it listens to that branch. Let's go to my settings for this particular app. Let's go to settings. And it says master branch. I'm going to now change that. It noticed I have another branch. It's connected to my GitHub. Now only when this branch changes. Save those changes. There. Okay. All right. Now, of course, it's gone and pulled that branch now. It's pulled my deploy render branch. The first time, it's going to go ahead and build that one. So we'll let that finish. In the meantime, we're going to switch back to our master branch. And we're going to make a change in a few minutes to our master branch. And now it should ignore that. It should not make any changes if we push master, only if we push our deploy render. And of course, what we can do is we can merge changes from master into our deploy and then push that. It's a little safer way of doing a deploy. That way you don't accidentally push master and trigger all these builds, which can get expensive. All right, this is almost done. So now it will only build if I push my deploy render branch. It saves me doing all these builds in case I push master a lot. I can take a look because right now, let's go to billing here. It shows you under free usage, I've used 7 minutes. Now you get 500 minutes a month. This is not bad. Build minutes. It looks like they take about a minute each, I'm thinking. So this is good. And you get one app running full time. So 750 is pretty much one app running 24/7 for a month. They give you for free. Okay. So your allowances are pretty good. But if I have a very active app and I do a lot of pushes on master, this could tick up pretty quick and I might end up costing myself some money. So what I've done now is in this app, now it is set to trigger off of the deploy render branch. So now if I make a change to my master, we'll call it anything app. Go ahead, commit that change, just say change title again. Go to change title, push master. There. Go back to render and nothing has happened. It's now waiting for the deploy render branch to change. Okay. All right. So that is how we push our app to a cloud service. There's many of them. I find Render's pretty good. All right, everyone. Thank you very much for coming today. Um, and this is our last React lecture. Have a great rest of your afternoon. Bye, everyone.